All right. Welcome to SageMaker Fridays. Today we're going to talk about automating ML workflows. So for this, my name is Shelby Eigenbrod. I'm an AI ML Specialist Solutions Architect at AWS, and I tend to spend most of my time in the domain of ML Ops. And here I have with me my colleague Michael. I'll let him introduce himself.
Hello, everyone. My name is Michael Xie. I'm also an AI ML Specialist Solution Architect at AWS. And I'm a data scientist by trade. And I've been focused on working with customer and working with teams that solving data science and machine learning problems together. And so, yeah, so thrilled to be part of this SageMaker Fridays.
Perfect. And for today, we're going to play some roles, between the two of us. I'm going to take more of the role or the persona of an ML ops lead or maybe a cloud platform engineer. And then Michael's going to take more of the data scientist persona as well. So won't be too big of a leap, I don't think, from our normal day-to-day activities.
Yeah, and we're going to have a very diverse perspective on these conversations. So when we're talking about automating machine learning workflows or ML ops, I hear a term a lot. This is a question I want to shoot to you, Shelby, first. I hear the term production a lot. What does that exactly mean? And so for a data scientist, I work using SageMaker Studio and build models in the notebooks. I use SageMaker managed training and processing that I learned from the AWS documentation to train the model and tune the models, and I'm ready to deploy models. But what does that mean by productionizing the entire workflow? How far is starting from a notebook from what you call production?
No, that's a great question. And it's one of those things, like the experimentation cycle with machine learning is different, right? Because you can go through experiments. You may even find out that a model isn't necessarily going to deploy to production, or it could be just an ad hoc model too. So not all models go to prod. Could be because they're not performing well. Could be because it's more of kind of an ad hoc, ML use case. But when we talk about going to production, we're typically talking about a model that deploys into a workload or has a dependency within a workload for things like availability, reliability. It's actually part of a production use case. So there could even be like SLAs behind it, right? Service level agreements that you have to be able to meet and maintain for availability and uptime and all those things. And some of those challenges that we see, like you said, most of the time a data scientist wants to start in, whatever IDE they're comfortable using. And, if that's a notebook environment, taking that notebook and then, taking all of the things that you did during experimentation cycles and then turning it into production ready code is a typical challenge that we see. And when we talk about production ready code, we're talking about code, that's scalable, it's secure, so you're not accidentally pulling in libraries or packages that have CVEs against them, like common security vulnerabilities. And then we're also implementing those production controls, right, to avoid human error, enforce governance, isolate those workloads in an environment that has those controls in place, and kind of avoid, accidental issues. We all make mistakes.
Yeah, and I gotta say, most of my data scientist fellows, we love coding, or writing, or analyzing data and build machine learning models in the notebooks. Because it really allows us to iteratively work through the exercise, evaluate the model, evaluate the data, and everything. And so, can I just give you, from data science perspective, give you the notebooks and code that goes along with the notebook, and to take it away for production, and maybe along with the train model artifact. Is that how it works, or is there any other things that we should be mindful of?
It's a great question, and it's tough sometimes, right? That handoff between kind of the model build activities and model deploy activities. And that typical path to production, like you said, is a data scientist wants to experiment inside a notebook. There are cases where data scientists kind of build out pipelines for model build activities from the beginning, but in a lot of cases, a data scientist wants to work out of whatever their favorite environment is. So in that case, like you mentioned, right, you kind of have a handoff point. In that handoff point, a couple things to kind of keep in mind is one, understanding model lineage, right? So we often use a model registry there to be able to track model lineage so that when you do that handoff, if you are in a notebook environment, the MLOps engineer or whoever's going to kind of deploy that model or put it in a pipeline for retraining understands the code that went into it, right? The exact versions of that code. They understand what input data was used. They understand where that model artifact is, that you want actually to take and get deployed out. And there's a couple of other things. A lot of times I'll spend time with customers on writing a little bit more decoupled code. So as a data scientist, and we'll kind of show you in a demo later, but as a data scientist, one of the things that is really helpful when you take all of those different steps from your model build process is if you can kind of decouple the code within those steps. So what that typically means is, you have your data pre-processing logic, and that's a piece of code. And you have your training logic, that's a piece of code. You maybe have model evaluation logic or any other code that essentially goes with the different steps in your machine learning workflow. And why that's important is what it helps do is be able to kind of decouple those steps, insert them into a pipeline, but also be able to actually gain efficiencies within that pipeline. So that way you can use the compute that best matches the step, so like your data processing task, maybe it needs just CPU, training, you may need GPU. So it's easy if you really write decoupled code to take that code and then put it into a pipeline and make sure it's in an automated workflow that can kind of easily deploy to production, but also implement a retraining strategy around it.
Yeah, and I think you touched on a very, very good point. And one of the main challenges for data scientists and fellow data scientists that, where we're experimenting things and we're creating a lot of different versions of pipelines or versions of ways of training the data, training with the scripts and so on and so forth, and it becomes very difficult to track. So really want to see, how this new workflow would look like and help data scientists to be more, well, I don't want to say this, but more organized, right? It seems that it has this, benefit to be more organized and be more automated.
Definitely, yeah. I mean, there's some changes, right? A lot of times in the way that you do things, but that is a perfect lead into a demo, I think. So in the demo, we're going to kind of focus on some of the SageMaker native options, right, in the area. So more specifically, we'll focus on SageMaker pipelines. So if we kind of if we switch screens, I'll go over into SageMaker Studio, and we'll kind of walk through SageMaker projects, which are basically templatized machine learning pipelines that also not only set up, the automated workflows, but also the integrations between the different components that we see. So your model build pipeline, your code repositories, model registry, as well as the triggers from model registry to actually deploy your model to an upstream environment. So for this, we'll take a look at SageMaker projects specifically. And are you familiar with projects at all?
Let's take a look at it.
Perfect. And these are just predefined templates. So there's usually different personas. So we're going to look at it more from the data scientist persona of I'm going to consume a project. But one thing to know, if you are an MLOps engineer, you're a cloud platform engineer, what these are behind the scenes are essentially CloudFormation templates. So you can, customize this to your use case, which we'll kind of show here in a second. So to be able to get to projects from Studio, you essentially go into this widget here. From the drop down, just select projects. And then we have a pre-baked project just to be able to kind of show things because some of these pipelines and that sort of thing take some time. But I'm going to show you the process for creating a new project. So you're a data scientist, you're going to get started on a new machine learning use case. You'll hit create project. And from here, you're going to see a list of SageMaker templates. So these are built-in templates. And these are built-in templates that are, owned, managed, maintained by the SageMaker team. And they cover different use case scenarios. So they cover everything from a full build, train, deploy pipeline to just build and train to also just deploy. And it's really just to provide extensible options for our customers on how they use projects. You'll also see organization templates. So organization templates are custom project templates that you build out. So this may be done by, your MLOps engineer, cloud platform team, whoever basically has skills in cloud formation, infrastructure as code, configuration as code. Because what they can do is then take a template, they can modify it to their use case. We'll also share a GitHub repository that has a bunch of, pre-built custom project templates to help get started. But what they can do is essentially take that and customize it for your environment. And what's nice about that is, as a data scientist, you probably don't care as much, right, about like security controls. You don't want to have to deal with that. You want to deal with building a model that performs, right?
Yeah, that's a mess. That's a messy or rabbit hole that we don't want to go into.
Yeah, and we don't want you to have to. So for this demo specifically, we're just going to use one of the built-in templates here. So I'm going to pick the MLOps template for model building, training, and deployment. You'll see over here, there's basically a description of each of these templates. This template in particular is going to use SageMaker pipelines, but it's also going to use AWS code commit for source code and then code pipeline for orchestration. But you can see here, there's also options to use third-party Git. So you can actually use a template and still utilize like GitHub Enterprise, GitHub, or Bitbucket Cloud. And then you can also still utilize Jenkins for orchestration. So if you're using Jenkins today, you can absolutely still take advantage of that.
Okay, so it seems that there's so many different options. For me, I just want to build some models and start training, and perhaps deploying into into SageMaker. Which templates would you suggest?
I would say let's get started with this one. This one is the one that's going to use AWS code commit for our source code and code pipeline for kind of orchestration of all those tasks. So I'm just going to click this one. You just select the project template. Depending on the project template that you pick, you may have different input that you need to provide. You can see here, the only input to this one is really a project name. And that project name is nice because essentially this project name gets carried out through tags. So the resources that actually get instantiated when you create this, they're all going to be tagged with this project name, which is nice when you're kind of searching for different things. You can know what components tied to, which specific project in SageMaker. So I'm going to put that in. You can optionally add tags, of course, which we always recommend, but I'm going to skip that for now and just hit create project. And then basically it's going to create a project for you. So this can take a few minutes, usually like 3 minutes, kind of depends on what your project template's doing. But let's take a look at what's actually happening under the covers. And again, as a data scientist, like this view just may not be super compelling, but a lot of times like the MLOps teams or a cloud platform team likes to see this view because then what it shows is really what's getting provisioned and configured under the covers. So while that project template is creating, you can see we're setting up basically this model build environment for data scientists. And part of that is setting up a code repository that has build code. And this build code is focused on your model building tasks. So it will have seed code automatically generated, which of course you're going to want to modify for your use case. But that build code is going to include like your data processing code, training code, your pipeline code. And you can see the other thing, it's setting up a lot of this build orchestration as well. So it's going to set up a code build job, which has, direction or a build script essentially for executing and your model build pipeline, which is actually being done through SageMaker pipelines. Again, we established some seed code just to kind of show you how to use it. And you'll see these triggers are automatically set up. So what it kind of means for you as a data scientist is when you are iterating through all those different experiments, maybe you're changing your code, maybe you're changing pipeline code like hyperparameters if you're using a built-in algorithm and it's your hyperparameters are just in your pipeline code, which we'll look at. Basically, you can just kind of interact with that code repository like you would get from your local computer. And we'll kind of show you how you do that. But basically, when you commit, it'll trigger a new pipeline build automatically for you because those integrations are automatically being set up for you. And it's also setting up a model registry for you for your particular ML use case, as well as the triggers from that model registry. So, when you find that model version that's actually performing well and you want to register it to the model registry, what that does is essentially, because we use the build, train, and deploy project, it sets up all those integrations so that when you approve a model version in a model registry, it's going to automatically trigger that downstream deployment pipeline that you see over here, which is, in the case of the built-in template, it's going to basically trigger a build process to deploy a endpoint called staging and an endpoint called production. And this can be modified, of course, with custom templates. But the idea is, like, you don't necessarily have to care too much about that, right? You just want to kind of be able to use it and get in there and build your model.
Yeah, it's I didn't realize so many things underneath under the hood that is being baked and being cooked while this project is being created.
There's definitely a lot being done for you under the covers, yeah. And if we go back, you can see the project successfully created. So, what it was doing behind the scenes there is instantiating, configuring all of what you saw before using a CloudFormation template. So if we kind of look at those components here, you'll see the exact same components, but they're available through the Studio UI. So repositories, you'll see that there is a model build and a model deploy repository that gets built out. And if we look at the model build repository, you can also clone the repository here. And what's nice about that is essentially, one, you can work out of this GitHub repository and your source code and continue to iterate on it from your local environment, and then commit changes when you want to trigger the pipeline. So I'm going to clone it here. But also what's nice about it is you don't have to set up those integrations that are triggering that pipeline under the covers, because it's automatically set up for you when you instantiated that project. So once you clone that repository, you can kind of see over here, basically this just cloned it to your local environment so you can work on your code from here.
And is this the C code that you just mentioned?
It is. What a great lead in. So yeah, so it does actually populate with some seed code. This is one of the things that customers will often create a custom project template for is, this is great for illustration purposes, but sometimes customers want to implement their own standards, or maybe it's a different use case where you're bringing your own container and you want your repos structured in a specific way. You can use a custom project template to essentially document the standards for your organization and create some skeleton, files of, hey, pre-processing code goes here, here's how it should look. Training code goes here, here's how it should look. But we can kind of take a look at this one that's already built out. What I'm going to do is bring up pipelines, Abalone, the good old Abalone use case. Do you do a lot of Abalone evaluation, Michael?
Yeah, Abalone's data set is definitely one of the most used data set for any machine learning tutorials and getting started. And so definitely familiar with this data sets, and it's a very interesting use case.
Definitely. And this is something obviously you can change, right? We do have a blog out there on like, how do you customize a project template? So this is something we, of course, expect customers to change. But you'll see here in this particular case, we actually are using a built-in algorithm. So in this case, we don't necessarily have a training Python file or training code explicitly because we're just passing in hyperparameters. But you'll see here that we have our pre-processing code. So this is our data preparation code. We have our model evaluation code, which is just your Python code as you would use when you're iterating, right? So there's really no difference in the code here. It would be the exact same code you're using to iterate on in your experiments. But the one thing that we probably should double click a little bit more into is the pipeline code itself. So I'm going to bring up this pipeline code. So this pipeline code is built out using a Python SDK. So it's the Python SDK for SageMaker pipelines. But probably the best way to look at it is comparing it side by side with an actual pipeline DAG. So I'm going to bring up pipelines here. You'll see this particular pipeline was automatically created through that seed code because the pipeline itself is created through that Python SDK. I'm going to bring it up, and you'll notice it's still executing because we just created our project. And when you create your project, it's going to essentially automatically kick off an execution of the pipeline using that seed code, or the seed code, the Abalone use case. So it's still going to be executing. But what we can do is kind of compare these two side by side. So let me bring up a different view. And we'll compare these kind of side by side here. And you'll see in this particular case, we have the visualization is provided through Studio UI. It doesn't necessarily mean you have to use Studio to use pipelines. You can use the pipeline SDK outside of Studio, but Studio is where you'll get the visualization of your pipeline. So if we take a look at this and we'll look at the code, can you see that okay, Michael? Is it looking all right? All right.
This is looking good to me.
Perfect. So we'll kind of walk through the seed code and then compare it to kind of the pipeline that's actually built out and executed. And the common steps for building a pipeline, and it's really kind of the same across pipeline tooling that you run into, are you configure the steps, you configure the pipeline, meaning you then take those steps that you configured and essentially say what order those steps should run in, what are the dependencies on those steps, and then you execute your pipeline. So let's look at this code that's in the seed repository. You'll see a lot of this is initial setup. So we're importing modules here, and you'll notice, I bet these ones look pretty familiar to you.
Okay, yeah, that's estimators that we've been using
Yep.
even in the notebook.
Yeah, so you're just using, kind of those same steps. If you're already using SageMaker training, processing today inside your notebooks, you'll see, I mean, it's pretty much the same code other than you wrap it around or it gets wrapped around or a pipeline. Wow, I can't speak. A pipeline gets wrapped around that code essentially. So you'll see a lot of those same modules that you import normally inside your notebook, but you will see one difference here, right? You'll see processing, but here's where you'll see kind of the difference. Here's where we're actually importing the modules that are specific to SageMaker pipelines. So here we're importing the different steps that are supported through pipelines. Like here's a conditional step. Most of the SageMaker native features that you'd want to integrate within your pipeline are going to be a native step out of the box. In this case, we do show SageMaker native options, but if you use something for data processing today, like EMR, I don't know if you use EMR typically, or Glue, you can basically extend out your pipeline using a native step like EMR, or a callback function, which is basically allows you to use other AWS services or even jobs running outside AWS. So we're just kind of bringing those things in here up front, getting our client set up, pretty much what we do all the time, right? Getting the session set up. And then you'll see here's where we kind of start to look at the pipeline definition specifically and how we're going to set up our pipeline. So within here, we're basically just, setting up our pipeline name, some of those standard things. But the one thing I did want to point out before we kind of look step by step is if you look at this section here, whoopsie, the pipeline parameters. So with parameters, what this allows you to do is essentially specify runtime parameters for your pipeline. So as an example, when you're experimenting, do you change your compute sometimes? Like, do you try to optimize for compute on your data prep or training or?
Yeah, and especially starting from experimentation all the way to, with full data sets, we typically realize that, hey, we need more memory or we need more CPUs.
Yeah, exactly. So that's one of the things that can kind of help with parameterization here is what that allows you to do is essentially pass in like an instance type or number of instances at runtime as you kind of iterate, as opposed to going in and changing your pipeline code every time. So you can take some of those configs and pull them out up to kind of the runtime parameter level so that you can kind of pass them in. It makes it nice too as you move from experimental environments or test environments to production environments, because then you can kind of pass that information in that's really kind of specific to the environment as well. So those are parameters. So those are just kind of identifying the parameters. And then here's where we actually start to set up our steps. So you'll see here, this is a processing step. Wow, if I could learn to highlight today.
These lines look almost exactly the same as I would setting up a processing job in the notebook using the SDK.
Yep, and that's a great point. And I think that's one of the main things is because sometimes, like we talked about, some data scientists will kind of build pipelines and iterate through them. Some won't. Some have like a handoff with an MLOps team that creates the pipeline. And what makes it nice is, like you said, if this is already inside your notebook code, it makes it a lot easier for the person that is going to kind of take it and put it into a pipeline because it's the same configuration parameters, right? So the move from that notebook environment to kind of a real scalable production environment is a lot more streamlined because you can kind of plug and play with the steps in your pipeline.
Yeah, and I feel that it's I'm very confident I can move the code from my notebook into this pipeline.py file.
Yeah, you definitely can. You're smart. No, yeah, like you said, I mean, it's Python based, which is nice, right? Of course, that's the preferred language for data science, I think. So like having a language that most of the personas that operate in the kind of ML land are comfortable with is really nice because it makes it kind of that easy transition. And you'll see here, kind of like you mentioned, it's the same thing. You're specifying your outputs. So here your outputs are trained, validation, and test data sets. And then you'll also notice, you can pass in job arguments. It kind of depends on the step. And all of that is documented in SageMaker documentation. And the same's kind of true for the training step. This probably looks pretty familiar to you as well.
Yep.
And again, this is just, XGBoost kind of built-in framework, built-in algorithm. But in the case, obviously, the supports bring your own model or bring your own algorithm. It supports all the different use cases of SageMaker. This example just happens to show the built-in algorithm. So here's where I was saying, like, as a data scientist, essentially because we clone the repository, I mean, you could modify the hyperparameters in here, commit it. Essentially what that will do is commit to that code repository that was set up and then automatically trigger a pipeline build for you. So if we look at this step and compare it to, let's compare it to the training step that's actually running now. Let's zoom out a tad. That's a big zoom. But if we compare this to the training step that's actually happening right now, you'll see all these inputs are what we actually specify. Let me move this around a little bit to create some room. But all of these inputs are essentially what we're specifying in our configuration here. And it's nice because you click on each stage in the pipeline here, and you're going to have your inputs, your outputs, your logs. But if we look here at training, you can see essentially, all the things that we're specifying through Python code in our configuration, they essentially become inputs to our training step here. The outputs are tracked, right? Which is nice for pipeline lineage in general, as well as for model lineage when we'll look at the model registry a bit. But you'll see here the output, like all of the training validation metrics are here. Any applicable logs will be available as well inside the console. So that way, you kind of have an easy way to track your pipeline status at any given time.
Yeah, that's super handy.
And these do take a while to run. They're doing a lot inside these pipelines, so the pipelines tend to take a bit of time to run.
I think it's done.
Oh yeah, go ahead. Sorry.
I think it's done. No?
Oh, look at that. It is done. Gosh, this is why you're the data scientist.
One thing I noticed is that in the script, I don't have to explicitly call .fit and .run for estimator and processors.
Yeah, that's a great point. And the reason for that is because of those built-in steps. Once you actually execute the pipeline, it's doing that equivalent for you, right? When the pipeline executes. Yeah, that's a great call out. And if we look, after we kind of configured all those steps for our pipeline, this is essentially where we put our pipeline together, right? So we determine what steps should the pipeline, or what order should those steps in the pipeline execute? Are there dependencies between the steps? So here you'll see we have this conditional step at the end here. And what this is really doing is checking the MSE value from your training metrics. And it's looking at whether it is, meeting the threshold that you've set for your objective criteria. And you do this through a condition, which is essentially a condition you set. And then that conditional step will actually check the condition to determine what's the next step in the pipeline. So here, if it does meet that threshold, you can see the next step is to register the model. Because at this point, it's probably a good, valid candidate to potentially move forward to a higher level environment. And then here's where we kind of stitch together all the steps. So you'll see here, we identify the parameters that are allowed in our pipeline, and then we configure the steps in the order they should run
in. So basically, we create the steps and put them in the list and put in the steps into the pipeline construct here.
Yep. Exactly. Yep.
So it seems straightforward. So what are the ways to run this pipeline?
It's a great question. Once again. So here, there's different ways to do it. You can do it programmatically, right, through a start pipeline command. But you can also do it through the UI as well. So to do that, you basically go into your pipelines. You can say create execution. Name it with some timestamp. I'm just going to put a random name here for right now. But here's where you'll see, those parameters that we talked about that you can change. This is where you could change your runtime parameters, or programmatically, of course, too. You could run your pipeline out of a notebook if you wanted to. And then we'll just hit start. So basically what that's going to do is trigger a new execution of your pipeline.
I see.
So that one did complete successfully. And remember how that last step was to register the model? And the nice part, like the register model, it's because it's embedded in your pipeline and register models, that native step, it basically takes all the metadata about that model, from like your training jobs and that sort of thing that are important in terms of like tracking model lineage and that sort of thing about your model. And it automatically populates that into the model registry for you. And if you remember, that model registry was set up for you as part of the project that we instantiated. So like if we go into our project here, this one's going to look pretty bare because it's a brand new project. But if we go look at it, because we have a successful execution of that one pipeline execution, you'll see we have one model version. The stage is none. Basically, it's not deployed anywhere. But the status is pending. So here is where you could essentially, if you have a peer review process or that sort of thing, a second set of eyes that takes a look at this version. Basically, you can go into it, look at some of the metrics around it, right? So you can look at your metadata. So you look at the inputs, outputs, that sort of thing to know, like here's the model artifact location. Collect some metadata about that model. And then you can also look at your model metrics as well. So it keeps track of those model metrics for you. And one thing I should have noted in all those pipeline runs, you talked about kind of experimentation. I guess one of the benefits of doing some level of experimentation through your pipelines is with SageMaker pipelines specifically, each run gets tracked as an experiment. So in SageMaker experiments. So even though it may not be like a great quality model that you necessarily want to, register into your model registry, it's still going to automatically track the metadata about that experiment. So like the algorithm, model artifact, how it performed, that sort of thing. So assuming this is a decent value, I don't know, would you pass this one along, Michael?
We need some reference.
Yeah.
But I would say this is a good starting point.
Let's pretend it's amazing. Yeah. And we're going to just say update status here. And you can, again, do this programmatically, but I'm going to set the status from pending to approved. Just say, it's approved for deployment to tester staging. And then I'll update that status. And what that essentially does when you update that status is it triggers the backend deployment. So in this picture that we looked at before, once I approve that, what it's doing essentially is kicking off a code pipeline execution where it's going to run through these steps to deploy to test, then deploy to a manual approval will be in the middle there. So it's more of a continuous delivery pipeline. And then once that's approved, it'll deploy to an endpoint called production.
And this trigger is automatic, right? So once someone approves the model, this will happen without any manual, coding.
Yep, exactly. And that's kind of the benefit behind projects is this is automatically set up for you because most of the time, data scientists want to focus on building great models, not this setup on the back end, right?
Yeah, that's a lot. It seems a lot of things to set up.
It is, and it's a lot to integrate together and kind of stitch together, which is one of the motivations behind, creating projects, creating pipelines together is just to kind of remove some of that setup activity and some of it, is still required, especially when you want to customize these. So say you want to add an additional quality check in here, additional step before it can actually deploy to the next environment. That's when your custom projects would come in, but it's still easier to kind of define and templatize it once and then make it available for reuse versus, each time I have to go and set this up over and over.
I have a question here. So who is the typical persona for the, to approve the model for deployment?
Yeah, and it kind of depends. I've seen some teams where they have like a peer review. A few teams that have, like a data science lead who goes and does the approval here on this particular side, right? On the model registry side. In terms of the deployment side, typically that's more of a DevOps, MLOps, whatever you want to kind of call that persona, that is that gate to production deployment.
I see.
Yeah, that's a great question. And maybe we can go check out, I don't know if you're interested in seeing kind of what that deployment pipeline looks like a little bit.
Yeah, absolutely. Absolutely.
Perfect. So, and you'll see like inside this view, it's ultimately going to end up changing to test as the first endpoint. Once it does actually deploy out to test, it does take a while for the pipelines to run, of course, but let's take a look. So we have a model deploy pipeline. You can see that I have my pre-baked one here, but if we go open this, if we look at the steps here for the model deployment pipeline, we saw the model build pipeline, which is essentially triggered by a change to any of your code, right? Whether it's data processing, hyperparameter, or your pipeline code itself. In this particular case for our deployment pipeline, it's triggered, or it can be triggered in two ways. It can be triggered by the approval in the model registry, which is what we did in this case, but it can also be triggered by the model deployment code. So when we set up those two repositories initially, we looked at the model build code, but there is that model deploy code as well that automatically gets set up, and we populate that with seed code as well. And that code is essentially CloudFormation templates to deploy your SageMaker endpoints, and then some configuration files to, change how you deploy your endpoints depending on your environment. Because typically you may deploy lighter instances in a test or staging environment than you would in a production environment. Or maybe even in test, you're going to deploy using serverless inference, and then prod, you're going to deploy using real-time endpoints. It's kind of flexible with those configurations and customizations. But here you can trigger it in either way. It's automatically set up as part of that project. And then you'll see it goes through a build script. That build script basically just takes the code from the code commit repository and puts it in S3 so that it can then be used in the next step, which is a CloudFormation step that's actually going to deploy, provision that endpoint. And you can see it's still in progress. These pipelines, they take a little longer to run, but that one is still in progress. We can go look at one that is actually already done. Let's look at this one. This one's run a couple times. Oh, go ahead.
So you're saying there's CloudFormation behind the scene that is standing up the endpoint?
Yep, exactly. The endpoint is actually set up in this step right here where it says deploy resources. So it's actually just executing a CloudFormation template here that is provisioning a SageMaker endpoint.
And again, that CloudFormation template is coming out from the C code, because I don't think we have gone through that. And data scientist, I really don't have much experience with CloudFormation template.
Definitely. Yeah. And like I mentioned, for the seed code on the model build side, you can work directly within Studio UI. You can do the same with the model deploy side. It just kind of depends on the persona, right? We have some teams that have kind of that full stack data scientist, I guess, if you will, that does model deployment. But then we also have a lot of teams that kind of have that handoff in between, where maybe the model deploy code is going to be modified outside Studio. But either way, let's look at the seed code here. And you'll notice inside the seed code, there's kind of a generic CloudFormation template, but then there's also two configs that I talked about. So we have a prod config and a staging config. So let's look at the prod config just to kind of show you what's in there. You'll see here is where we specify, these are the configurations that are really specific to our production environment that we want to have in place. So, this is the number of instances, this is the size we want to use, sampling percentage, enabling data capture for model monitoring, that sort of thing. And then that config is used depending on what stage in the pipeline. And again, this is all set up for you essentially. But depending on the stage of the pipeline, that config is used and injected into this overall CloudFormation template, which you can see packages that model. So this is where we're kind of doing that logical packaging of the model for deployment to SageMaker, creates the endpoint configuration. So how do we want that endpoint to look? And then it's actually provisioning that endpoint with SageMaker. And one thing to kind of point out here is you'll notice this kind of throughout the pipeline, that project name ends up getting tagged with all these resources that get provisioned, which is nice because, for that specific endpoint deployment, it ties specifically to the SageMaker project.
Oh, okay. Wow. Well, this template has been templatized so that we don't.
Yeah, exactly.
We don't have to spend too much time, recreating the whales,
Yep.
reinventing the whales.
Definitely. Yeah. And I mean, you can reuse all this code. And I definitely suggest people do that, as they kind of create their custom project templates. Like, you can absolutely reuse a lot of this code, modify it to your use case. That's typically what I do. I don't start from scratch very often. I do a lot of borrowing. Let's see. And the one thing to kind of highlight here is, oops, we talked about the model registry. So it goes through those deployment processes. I'm going to bring up a project that is pre-baked, right? Because it takes some time to go through these in demos. But if we to look at the model group for this one, so this is the model registry, you'll see here where it does change to prod. So ultimately, this model has gone all the way through the pipeline, model version 1, where it's deployed in staging and prod. And you'll see we have a second one here. So if I click approve on this one, what it's going to do, again, is kick off that deployment pipeline, deploy to tester stage first, and then wait on that manual approval to then deploy to prod. So this is where you would see where a particular model version is deployed at any given time.
Were they? It seems that they're a staging environment and also prod environment. What are those, and what should I look out for in each of the stage?
Yeah, and that's a great question. So with the built-in templates, you'll see with the naming, prod and staging are really named around kind of the intent of that endpoint. However, so you'll notice when the endpoint deploys, it's actually named with prod. The endpoint's named with staging. The one thing though to keep in mind is, a lot of times not a lot of times, we do recommend multi-account strategies to customers for kind of workload isolation on AWS. So most often customers are actually deploying these to other environments. And when I say environments, I mean AWS accounts, because in this particular case, we're deploying to the same AWS account. So to be able to do that cross-account deployment, there's actually a really good blog for SageMaker Pipelines cross-account deployment that shows an example of a custom project template that deploys across accounts, which is a super common pattern that we see. So that way, in this particular case, the stage here is more of a naming of that endpoint in the existing AWS account. Whereas if you want to deploy to a separate AWS account, you'll want to use a custom AWS project template. And definitely, I would start with the base examples that we have.
So you're saying that different stages are for different purposes, and we want to separate the traffic for evaluation or for testing and for actual requests from our clients into different places.
Yeah, and in each use case, each customer environment is a little bit different. We see staging used a lot for kind of more integration testing too. So like once you get that endpoint deployed, integrating it with your client applications, testing it out, making sure your inference logic matches the way the model was trained. And then we typically see prod as the kind of live model, right? The one that is actually considered in production, has all those same production controls. But ideally, staging to prod, you're going to have those same controls in place in terms of like security, lockdown, all that sort of thing.
I see. That really clarifies it.
So I don't know, what's your impressions as a data scientist?
Yeah, I think I just big wow, and I now have much better understanding on the path to production from where I were before, like just training or building models in a notebook, and it seems that SageMaker projects and SageMaker pipelines really makes it very easy to adopt the MLOps best practices, especially as you just explained, all the pipeline executions and model registry, and the multi-staging deployment, which is really opens my eyes and and I think it makes the production much easier in my eye, because I used to think that is a lot of coding, a lot of manual, checking in and manual configurations and stuff like that. But it just seems that it's very straightforward with what you just showed me.
Nice. Yeah, we definitely want to continue to focus on that data scientist experience and make it easier, right? At the end of the day, we all want our models in production, right? Actually driving some business value. And we
Yeah.
do have, just for kind of reference, there's a GitHub repository here that has some example of custom project templates. So these are really kind of patterned around a lot of the ways that we see customers using projects today, and some of the like custom patterns that they're asking for. So this one is actively updated. We'll continue to add patterns here just to avoid having to, even, like for MLOps engineers, DevOps engineers who are, super savvy in CloudFormation, we still want to make it easier for them as well to be able to like pick up patterns automatically, tweak them a little bit to meet their use case, and then just kind of run from there.
Yeah, it seems very helpful. I'll definitely let my DevOps engineers or MLOps engineers know about this place.
Definitely. Perfect. I mean, I think that wraps it up. I think we're at time. But personally, I just want to thank everyone for joining. I'm sure Michael has some comments as well, but connect on LinkedIn. Happy to talk anytime about this topic.
Yeah, this is a wonderful, demonstration, and really helps me understand ins and outs of MLOps using SageMaker. Thank you, Shelby.
Awesome. Thank you. Thank you all for joining as well.
Thank you for joining. Bye-bye.